Welcome, dear students. We're going to do our functions today, and this is our lesson 3, where we are talking about the hyperbolic function. So I hope you're going to enjoy this lesson right here. So to start with, we're going to actually start to draw a basic hyperbolic function. So a basic one would just be like this one, which is just 1 over x right here. So that's the graph that we're going to draw. It's the standard graph. So to actually draw this graph, I have this table laid out in advance for us. So you know that if you substitute x of -2, you have to say y divided by -2. You see, that's how you get this -1/2 that's here. The same applies when you substitute -1, you get this. Normally, I would use the same scale. If I go -2, -1, I'll go to 0, 1, 2. But you will understand just now why I had to choose these ones, for the shape to be clearly visible. So notice if you substitute -1/2 here, you will definitely get -2 in this equation. So I'm pretty sure that as for filling in the table, that you can do. So we are going to also draw the standard graph using the same table, and you'll be surprised how the standard graph looks like. Look at it. It's already drawn in advance for us. All the points that we had, like you can see here at -2, you see this coordinate of ours here. We had it -2 and -1/2. And of course, this one is our -1, -1. You are noticing that these coordinates are exactly where they should be, isn't it? But the interesting part is when you go to a half. A half, notice where you will be. Now you're on the other side. And then these points, as you go with your table, this is how you draw those points. Luckily for us, the graph is already drawn. You can see that it has 2 arms. This one here at the bottom that you're noticing, and then this one up here. So that's the arm that we've got as well. I call them arms. So we have 2 of them for the hyperbola, and this right here is the standard graph. So that's the shape we should be expecting on a hyperbola. Well, with time, you will see that I'll label my quadrants. I'll label this number 1, number 2, number 3, and number 4, the quadrants. So you're noticing that our 2 arms are in quadrant 1 and quadrant 3. The one thing that is very clear to see here is that we have asymptotes. You can see that the y-axis in this situation happens to be the asymptote as well. You can see it's a dotted line, blue, meaning it's an asymptote this time. And all along the y-axis, it is actually x, which is equal to 0. So that's the equation of that asymptote right there. Another asymptote that we don't want to overlook is the horizontal asymptote. Let's try to, this one right here. So this one all along the x-axis, y is equal to 0. So that is the equation of the asymptotes. You can see that that's one thing you have to keep in mind. There's got to be asymptotes on this graph. Well, everything else that's written here, like your lines of symmetry, you can see that we have this line here, which is the x line of symmetry, this one. It's cutting the half, the function into exactly 2 equal halves. And it's not the only one. We also have this function right here. Well, these are the properties you have to keep in mind, but I will be going through these type of things slowly but surely. So for now, this is just the graph. I wanted you to see the shape of a hyperbola and then carry on. So here on the horizontal asymptote, I hope you still remember we said the equation is y is equal to 0, and on the vertical asymptote, we said that the equation is x is equal to 0, which is the y-axis, isn't it, people? So notice the definition of an asymptote here, just so you know, a line that a graph gets close to but never touches. Don't touch your asymptote. It's somewhere where you shouldn't go. Well, the domain and the range, we will talk about it a lot more as we go, but it's important to just take a quick look at it. You can see that everything else is included except for x is equal to 0. You will understand all this as we go. You can see that's where your asymptotes are as well. So let's go about it slowly. Firstly, just keep the shape in mind, just know that the graph looks something of this sort. If you have to draw the graph of 1 over x, it will look like that. Just don't touch your x-axis. This is your y-axis, and that will be your x-axis. That's all I want you to pick up from this graph. Well, after you pick that up, now I can talk about other things, such as the effect of A. You will notice that this function, in a few minutes, you will notice that we will change this function to something of this sort. Function of x is equal to a over x minus p plus q. We will do it this way. So this basic graph that we had over here is going to be shifted up and down, left and right, and we're going to actually reflect it every now and then. And that will be the effect of these parameters that we added, the parameters such as A, such as P, and Q. So each one does something to this graph. So to understand well, this one right here is actually the effect of A, this one right here. You can see that if I were to reflect the graph, which we said was the graph of 1 over x, this one right here, you can see that y is equal to 1 over x here, isn't it? So this is the shape we agreed right here. So if you reflect it on the x-axis, or let's rather say, yes, it's fine. Let's do, say, on the x-axis. This top arm here is actually going to come down here like this, which will be this arm. And this red one over here, this bottom part, the one in the third quadrant, when you reflect it, it will come over there as well. So as you can see, this is how we will get to the blue graph, this one. So we are saying if you reflect the hyperbola in the x-axis, even if you reflect it along the y-axis, people, it's actually going to be the same thing. You will have this graph. But when you reflect on the x-axis and on the y-axis, what you're actually doing is just to make, if you reflect on the x-axis, you're making y negative. If you reflect on the y-axis, you have to make x negative. But either ways, you will see that the other graph will just look, the equation of the other graph would just be negative 1 over x, just like how it's shown here. So, if I may wind this up easily for you to see, because it may be difficult for you to understand from your notes, I am saying if your A, this A, the number over there, if it is positive, you will have to draw the two arms in the first quadrant and in the third quadrant. That's what you have to pick up. So whenever A is positive, you put your quadrant 1 and 3. If A happens to be negative, okay, writing the whole negative is a lot of work. So if A is negative, you work in quadrant 2 and quadrant 4. I think it's clear to you to see. Notice here A was 1. We are in quadrant number 1 and quadrant number 3. Here it's quadrant 2 and quadrant 4 because A is now negative 1. So now that's one thing you have to keep in mind. It's a very important thing as we carry on with this. All right, so now that you have that, let's go and talk about the effect of another thing. Let's talk about, remember I say that we are going to now see this graph like this, right? So we want to talk about the effect of A, P, and also Q. So those, we call them the parameters. You see, these are the parameters on the graph. Now, let's first of all talk about changing Q. So we would like to talk about changing Q, which is this part here. What happens when you change Q? So I would like you to know that it's a vertical shift upwards if Q is greater than 0. That is, if it's a positive number. And if Q is a negative number, you shift downwards. So it's a translation on the y-axis. You know, it sounds too fancy when you start saying all that. Let me just write one example. Why don't I take 1 over x, the graph that you already know, and I say plus, why don't I say plus 3? I like 3. So what it means is that you are taking your old 1 over x graph, you know, let me just put it like this so you can see it. We're going to make just small sketches. This was the graph of 1 over x, isn't it? And this one right here was your y-axis. These were your asymptotes right here, this one and that one. The graph was not touching those ones. So this was the graph of 1 over x. I am saying if you shift it 3 units up, this is what is going to happen. Let me try to draw proper graphs. Okay, so this is what is going to happen. You're going to shift the horizontal asymptote. So notice here we were at 0 here. This was x is equal to, no rather, y is equal to 0. This was the equation of the asymptote. Now you're going to have to shift it upwards, 3 units up. So you shift the asymptote 3 units up. Let me do this. Let's do that. So now here is where your asymptote is. This takes too much time. Okay, let's try harder. Maybe not. Right, let's just leave it there for now. Otherwise, we'll spend all the time looking at it. So it's now at 3. In fact, let me just do it in red like this. So that's where your asymptote goes. And once that is established, remember, we changed only the horizontal asymptote. The vertical asymptote is still on the y-axis like we have agreed. It's still right here. So this is still our y-axis, but our horizontal asymptote is no longer the x-axis. It is now this line right here, which is y is equal to 3. So now that is where the graph is not supposed to touch those lines anymore, those red lines. So how do we draw this graph? Remember, because a is positive, a is 1 this time around, so we should be working in the first, which is this quadrant now, and the third. And I want you to be, you find where your cross is, like right here, where your asymptotes intersect. So this is your quadrant number 1, your quadrant number 1. This whole thing here is your quadrant number 2. This whole thing is your quadrant number 3. And here is your quadrant number 4. So when you draw, you no longer worry about the x-axis. You're just worried about the asymptotes, the lines that are in red. So when I draw the other arm, I'll have to just watch for my red lines. It should look something of this sort. So if you move the graph of 1 over x and you move it, you put a 3 there, all that happens is that the graph is going to shift 3 units up, and the graph will look exactly like this one over here. That's all there is to it. It's actually that simple. So you may have to find, however, this coordinate. Let me call it A. In this situation, A, we call that one the x-intercept. The x-intercept, all you need to do to get it is to put y of 0. So you go to your equation, and in place of y, you put a 0, and then you go and write 1 over x plus 3. And then you solve. So you're going to just have to take negative 3 to the other side, and then you say 1 over x. At this point, if you cross multiply, you get negative 3x is equal to 1. And then your x will be negative 1 over 3. So at this point, I know that this coordinate here is at negative 1 over 3. So that will be the coordinate of A, negative 1 over 3 and 0. Okay? So that's all there is to it. So in other words, if I may just give you a summary of this, just know that Q represents the horizontal asymptote. So if you want to find out the horizontal asymptote, then it's Q you have to look at. Okay? Sorted like that. If it says plus 3, you go 3 units up. If it says minus 3, you go 3 units down. While we are still at it, why don't I give you another example? Let me just do this and give you another example. The second one that I would like to talk about now is, let's say I just give you a function and I say, well, function of x is equal to 2 over x minus 5. How will you go about sketching that one? Well, from what we gathered, we first of all draw our y-axis. This thing is going to waste my time. Let's see. Your y-axis and your x-axis. Right. Okay, so after you draw your y-axis and your x-axis, then the next thing you do is to make sure that you put your asymptotes first. So, as we have already noticed, the asymptote, especially the vertical one, it has not moved. It is still on the y-axis. This one has not been moved at all. There is no shift left and right. So it's still right here. But we have shifted this graph, and we have shifted it 5 units down because of that -5. So the horizontal asymptote will have to move 5 units down. From the x-axis, it will move 5 units down. So here is, I normally prefer putting it as dotted lines. Here is your horizontal asymptote. Right here, right? So it is on -5. Now, if I may ask you, which quadrants are we supposed to be in now? If you look closely, what's your A value? Well, since your A value is 2, you still have to work in your first quadrant. You know that the first quadrant will be, this one will be the first, second, third, and fourth. So you have to go, you use your asymptotes to figure out your quadrants. So you are in the first quadrant and in the third quadrant. So how do I draw this one? Well, notice I'm going to put that graph right there. So it is going to just be like this. You see, I'm being careful not to touch my lines at all, my asymptotes. And then even here, I'm going to go to the third quadrant, and notice I'm not going to touch my red lines. So those are our asymptotes right there. So as you can see, this will be the graph. All that happened was that we shifted 5 units down. Okay, right? So maybe I should ask you now the equations of the asymptotes this time. What would you think are the equations, the new equations of asymptotes? Let's see if you can tell me. Well, as you have noticed, the vertical asymptote has not changed. It's still at the same place, and all along the y-axis, x is equal to 0. So the equation x is equal to 0 is still the vertical asymptote. But when it comes to the horizontal asymptote, now we have to talk about this one over here, which is at y is equal to -5. So I really hope that you're noticing what Q does. In fact, we just say that it was the horizontal asymptote, and it's a shift on the y-axis. Let's talk about P quickly. Right, so P is not going to do something too different. So if you change P, you just know that it is a horizontal shift. It's that simple again. So to get going, I'm going to take your graph that you already know, and I'm going to write it like this. But with P now you have to be careful, huh? Notice even in the equation that I gave you up here, to your left and up there, okay? So notice P was x minus P plus Q. So that's the drag here. The number that's here, you are seeing that it's saying -3. But in actual fact, we are going to move 3 units to the right. So it means if it was plus 2, or something else, which is positive, you are going to move to the left. So please notice the changing of signs as we go. So how does this work? If I want to sketch a graph of y is equal to 1 over x minus 3, I won't struggle with that because you still put your y-axis and you still have to put your x-axis, and then you have to think of where your asymptotes might be. From what we have gathered, the asymptote, this time the vertical asymptote, this one right here, the y-axis, is the one that's moving because we are moving left and right. So we are going to shift that vertical asymptote 3 units to the right. So your new asymptote now is going to just be here at 3, like that. It just has to be a straight line. Just watch out that it is. Mine is not going to be straight anytime soon. Okay, so this one will be at x is equal to 3. The other asymptote that we have, remember, this time around we are not shifting the horizontal asymptote. So this will be the other asymptote available right here. So now you have to check your quadrants. Quadrant 1 and 3 is where we are working because we have x of 1. So you just sketch your graph as close to your asymptotes as you can, depending on the steepness. We say that A, if maybe I didn't mention it, A also affects the steepness of the graph. So as A increases, the steepness increases as well. So it's another thing to keep in mind. Although A, we mainly know it as something that tells us the quadrants in which we are working at. So this will be the new graph. As you can see, it was shifted 3 units to the right. If you would like to find the equations of asymptotes, you will easily, the equations of asymptotes this time, let's write them down before we forget. So what are you going to say? You have to talk about the x-axis, which is the horizontal asymptote. This one right here. Let's highlight it. This one right here, you can see is the asymptote this time. So what is the equation of the x-axis? At y is equal to 0. Well, then another asymptote that's there is the vertical asymptote, this one. And as we can tell, it's at x is equal to 3. Okay, so if I say x minus 3, like I've said here, the equation, you see, I said 1 over x minus 3. What happened was I moved 3 units to the right. So maybe you're wondering what will happen if I say, let's do this one. If I say y is equal to, why don't I say 1 over x plus 2? Where do you think we have shifted this time around? Well, notice we have shifted 2 units to the left. And I would like for you to appreciate the fact that P itself, P denotes, it actually represents the vertical asymptotes. Okay? And Q, if you remember, Q represents the horizontal asymptote. So those are the key things to keep in mind as we are going on with these graphs. So I'm going to sketch this graph so you can see the differences as it moves. It's just important to see how it moves. We will also perhaps have a lesson on this on GeoGebra, just so you may know about it. All right, so your asymptote is now going to be shifted 2 units to the left. So your asymptote will now be right there. So that's your new asymptote at -2, right there. So the horizontal asymptote has not been shifted this time since there is no Q. So your horizontal asymptote is still on the x-axis right here. Okay, so I would like for us to just quickly sketch this graph, just a sketch. As you can see, I have to work in the first quadrant and also in the third quadrant, like that. Just be sure not to cut anything. Well, I think you've been noticing that I've been leaving out these ones. It's not really a good habit to leave it. So let me go and calculate the y-intercept. So if I call that A, let me call it B, since I once called something else A. So this one, let's call that point B. So B happens to be the y-intercept of this graph. And to get the y-intercept, all you have to do is to make x 0. So I'm going to substitute into the equation this particular equation here, and I'll put x of 0 over there. So it's 1, 0 plus 2. As we can all see, y should then be a half. So you have to put these critical points as well on a graph when you're sketching it. Okay, so the asymptote carries on in that situation. So I think you're noticing what's happening here. Let's see if we calculated this one. We didn't. Bad. So here, come here. Do you see this one? This is when the graph cuts the y-axis. So to get the y-intercept here, I'll have to put x of 0 in that equation. So I'll have to say 1 over 0 minus 3. Can you see that will be negative 1 over 3 right there? So I hope you are seeing what's going on here, because now I'm going to give you a graph that has everything inside, A, P, and Q. And then you can see how to sketch such a graph. Okay, so now that we are here, we have everything. Everything has been said. Now I think it's about time I also talk about the domain and the range, but let it wait for a second right there. So we'll talk about this domain and range very soon, okay? So we'll talk about it. Right. For now, let's have one example of a function which has got everything that we were talking about so far. What happens if they give you A, P, and Q in one sum? For example, this question. Why don't I start small and put the things we're doing just now? So let's say you have 1 over x plus 2 plus 3, like that. So according to what we know, at this point, your A is actually equal to 1. Your P, watch out, your P is negative 2, and your Q happens to be 3. So with that in mind, can we sketch such a graph at all? Are we able to sketch such a graph? And the answer should be yes. So we are going to put the y-axis as usual. We put the x-axis as usual, but these ones are not going to be asymptotes anymore, these ones. The new asymptotes are P and Q from what we learned. So let's put the asymptotes now, because to be able to sketch this graph, you will need to see your asymptotes. Concerning P, look at this point here, it's x plus 2. It means you're going to have to shift 2 units to the left. So this one here will be negative 2, 1 down. What about the vertical shift? Well, we see that one on this number here, and that is actually at positive 3. So the vertical asymptote should be here at positive 3, right there. So here it is. So the moment you have your asymptotes, wherever they intersect, that's where you have to watch out to be able to name your quadrants properly. So I'm just going to make sure it's a bit longer, because we have to be in which quadrants? Yes, let's hear from you. Which quadrants should we be in? Well, as you remember, I said you look at the A value. So the A value is 1. It means we should be in quadrant 1 and quadrant 3. So it would be wise to actually, and it would be correct, to draw my graph in that quadrant. Are you seeing that I'm not touching my asymptotes? Like that. And then the third quadrant is this side. So this is where the arms will be, right there. But at this point, you're noticing I just sketched it. The steepness of the graph, I just decided to put a certain steepness. It's because I didn't calculate my intercepts first. The graph is correct, but we need to put the intercepts first. So we need to be able to calculate. Let's start with the x-intercept. Do you know what we just agreed a few minutes ago? If you want to calculate the x-intercept, you have to make y 0, like this. So let's go ahead and put 0 in place of y. Function of x and y, 1 like the same thing. So 0 here, then 1 over x plus 2, and then plus 3. Please watch out here. All you need to do is to take the number to the other side. Okay? And then you say is equal to 1 over x plus 2. Like that. And then from here, definitely what you have to do is to cross multiply. When you cross multiply, let me show the step. Negative 3 should multiply x plus 2. Notice negative 3 is negative 3 over 1. So when you say 1 times 1, you should get 1 there. Just to make our lives interesting, I'm going to just show that step as well. Right? So negative 3x is going to be equal to, is that going to be 5 when it goes to the other side? So as you can see, our x here is going to be negative 5 over 3. So that's our x-intercept in this situation. So where do we put it? We go back to the graph. This point is actually negative 5 over 3. So negative 5 over 3 is some, is that negative 2, and then this is negative 5 over 3. This is too interesting. It can't be. It's not possible that it should be negative 5 over 3 here, no ways. So it means when we were calculating the x-intercept, let me go back there, here at this point. Something must have gone wrong here. Let's see. This is fine. Oh, seriously. 1 plus 6. This one right here should be a 7. Okay, let's put it. This one should be a 7. And therefore, when you divide by negative 3, then you should get negative 7 over 3. Well, now it looks more like it. Perfect. So now I'm going to go back there and put negative 7 over 3 as our asymptotes. It makes sense now. All right, good. So that is our x-intercept, rather. So this is how we calculate that one as well. Now, I think you're looking at this one and you're eyeing it as well. That one is called the y-intercept. So why don't I calculate that one over here as well, the y-intercept? All you need to do is to put x of 0. This one is rather simple to do. Let's look at our equation. Okay, over there. Hope you can see it on top. So it's 1 over 0 plus 2, then plus 3. So when we do something like that, we should get a half plus 3. That will also be 7 over 2, isn't it? So a half here for this one. So this answer will be 7 over 2 as well. So here it's 7 over 2, 3.5 in general. So as you can see, this will be a full graph that has got both P and Q, and also A is involved here as well. So this is a full-on hyperbola. It looks like this. So there is nothing serious that we are noticing here that may scare us a bit. So there are just two things I want to talk about on this graph before I leave it alone. You're noticing that I'm interested in the domain and range, like I've already said. Well, just notice, however, that on this graph, this blue graph can go all the way to the right for as long as it can. It means it can go to positive infinity. And the other arm, if you look at it, it can go all the way to the left the way it feels like. So it means all the way to negative infinity. The only x value that is not involved is the part where it's discontinuous. That is at negative 2. So when you want the domain of such a function or of something of this sort, all you need to do is to say x is an element of real numbers, which means all of them, but we have to exclude where the asymptote is. And this time around, it's at negative 2. So that would be your domain right there. Okay? So now that that one is sorted, I also want you to understand that the range is equally as simple. If you would like to calculate the range, this graph includes all y values. Why am I saying so? This upper arm, look at it, it can go all the way there. And this bottom part can really go all the way down. It means it can go to negative infinity and positive infinity, but the only value of y that's not included is even discontinuous at that point. That's that y is equal to 3. So that will be, that will actually be our discontinuous part, so we have to just say y is an element of real numbers, and we emphasize that y should not be equal to 3. 3, right? 3, yes. Just go back to this part here for the domain. I think what you remember is that if you put anything over 0, it becomes undefined. So if the function says y(x plus 2 plus 3 like this, if I put x of negative 2 here in place of x, you are noticing how that will make the denominator 0. And once the denominator becomes 0, the whole thing is undefined. That is why we are excluding negative 2 on our domain. There is also something called the axis of symmetry. I want to talk about it now quickly. So the axis of symmetry, like I've already indicated at the beginning of the lesson, those are the line that cuts the graph into 2 equal halves. It's just 2 of them, actually. So the axis of symmetry is going to be this one. Let me sketch one. I hope you guys are seeing which one I'm not sure whether I should cut on 7/2 or before, but what we are sure of is that it should cut at that point where the asymptotes meet. So there are 2 axis of symmetry lines. So this particular one is the one that has gradient of positive, which is 1. So to get the equation of that one, you just have to say x plus c. There are 2 of them, like I've already said. The other one, you just get it by saying y is equal to negative x plus c. So all you have to remember is that the axis of symmetry for a hyperbola, one of them has positive 1 gradient and the other one has negative 1 gradient. And they both pass through the point where the intercepts, rather, the asymptotes meet. At this point, it will be at that point right here. So the coordinate for that point, the x coordinate is negative 2 and the y coordinate happens to be 3. So we're going to use negative 2 and 3 to get our c value in both equations. So I'm going to write it as 3 here. And I'm going to put negative 2 here plus c. As we can see, our c value is going to be 5. So one equation of the axis of symmetry will be x plus 5. So I was right. It looks exactly like that. So the equation of this one is y is equal to x plus 5. That's the axis of symmetry. Well, the other one, which comes like this, this one has got the gradient of negative 1. It will be this one. So for us to be able to draw it properly, let's get it. I'm going to still substitute this coordinate in. So 3 is equal to negative. It's also negative 2 there. So as we are noticing, this is going to be 3 minus 2 eventually. So it should be 1. So the equation will be y is equal to negative x plus 1. So just like we have already indicated. So the y-intercept here will be at 1, right there. All right, so that's one thing I wanted you to pick up as we are doing this. So it's all A, P, and Q are included, and I just gave you one example. So I feel I should give you 2 more examples, just so you may appreciate this one. So let's go, I'll give you the other one. What if I say, let's have this one. G of x. Let's call that our number 2. I want you to try sketch it on your own. So gx is going to be equal to, again, let's use negative 2 rather. Let's rather use negative 2 this time. So negative 2 over x plus 1. And then I would like to put, let's say, negative 2 like this. Well, go ahead, sketch it, give me the axis of symmetry, give me the domain, give me the range, if you can. Okay, so I think you tried it already, so let's go and see what happens. So I'm going to put the y-axis getting ready for the graph, and the x-axis, let's put them there. So now that they are here, let's put the asymptotes. Where are the asymptotes? Well, the vertical one has been shifted 1 unit to the left. I'm going to shift 1 unit to the left. Right there, at -1. Sorted. What about the horizontal asymptote? You look at this one. So that one, you take it together with the sign. The sign you change is for the one with x. The q value, you take it as it is. If it is -2, it means you're moving 2 units down. So it means our horizontal asymptote is here at -2, where that one is -2, that point. So that is what we've got now. The only thing remaining is for you to pick up the quadrants we should be working right now. So I am waiting for you to think about it so we can put the quadrant properly. Well, our A happens to be -2. The moment A is -2, it means you're working in quadrant 2 and quadrant 4. This is how you number the quadrants, like I said. You come to where these asymptotes intersect and you number your quadrants. I'm not going to keep those numbers there, but it's important just to know where your quadrant 2 and your quadrant 4, where those ones are at. So let me put the curve in quadrant 2 right now. So I'm picking one arm. It's a habit of mine that I draw this without my x-intercept, but I'm sure you have your x-intercept first. That will be good manners, this one. Right here, we need that coordinate. You have to calculate it first, actually. All right, and then the other one will be in the 4th quadrant. So as close to your asymptotes as you can, just pass through the correct y-intercept, and then you should be ready to go. So this will be the graph. It's an acceptable graph for this function. It's just that I need to find those points. I'm going to call those A and B. We desperately need our intercepts for us to draw correct graphs. You will see that on some graphs, it's not possible to just get away with sketching it before you get your intercepts. In fact, let me give you that one as the next one. Okay, let's get A. A, the x-intercept. I think you know now we have to make y 0. So I'm going to put 0 in place of y already, and I'm going to say -2 over x plus 1 minus 2. So I take 2 to the other side. That doesn't look tidy. Let's try again. X plus 1. So if I take 2 to the other side, it will be +2. I think now you have the idea of what's going on here. After this, I'll have to cross multiply. 2 should multiply with x plus 1. And since this is 2 over 1, -2 times 1 will still be -2. To wind this up, I'll say 2x. I just have to be careful now. The last time we did this, things didn't go too good for me. So at this point, we are noticing how 2x is actually going to be -4, and our x is -2. Let's see if the graph agrees with what I just said. Well, it's acceptable that that should be -2. So that is our x-intercept. You have to have it first. If I had it, maybe I was going to pass via here, but it's fine. We can say that's -2 where that is right there. Okay, the last thing I want you to do on the intercepts is to calculate the y-intercept. And calculating the y-intercept is not a problem. All you have to do is to make x 0 for this one. So to do that, just go to the equation, put x of 0. Our equation, what is it? -2 over x plus 1. So it will be -2 over 0 plus 1. -2 over x plus 1 minus 2. Okay. So this is easy because our y will now just be -4 right there. So this point, oh my, now I feel bad. It's -4. So I do want to draw this one again. Okay, let me try harder. This one that's there is not really doing any justice to me at all. So the curve must actually look something like this. So now I think you know that At least that would be a bit better, right? And then we can now say this is -4. It's a little bit far away from -2. It makes a bit of sense. So please, people, that would be your curve right there. You have everything that you needed. So this is GX. If you wanted to just sketch it, you are sorted when it comes to sketching. Well, there are other things I asked. So let me just create a bit of space so we can do those things that we asked while looking at the graph properly right here. I asked that you should be able to give me the domain of the graph. Are you able to give me the domain right now? I think so. So it's x is an element of real numbers, and which x value is not included this time? You just look at the asymptote. So x is not equal to -1, like that. And what about the range? The range involves y. So you're talking about y right now. Which y value is not included? Well, you just have to look at the asymptote. Y should not be equal to -2. You know that. You get it over here. And if you remember something else that I said you should be able to calculate the axis of symmetry, the equation of the axis of symmetry. So I said there are two of them. You don't have to draw them all the time when you're asked. You just have to be able to do it. How do you get them? I say just know that the other one is positive gradient. Just calculate your C. That's all you need to calculate. And the other one has a gradient that's negative. Like that. And which coordinate do you use to get your C value? Well, if you were listening, you go to where the asymptotes intersect. Right there. The x value at this point is definitely -1. And the y value at that point is -2. So you're substituting P and Q here. So it's -1 and -2. So let's go and substitute them into these equations so we can carry on. -2 in place of y. I'm putting -1 in place of x. So I hope I should be fine here when I do that. Okay, so our C will be -1. So this equation will actually work out to be x minus 1. So if you want to sketch, if you want to see that axis of symmetry where it should be, so it will just pass through here. Notice. Like that. And this point here is -1, the y-intercept. They all should pass via that point. The other axis of symmetry is the one that cuts like this. They should all pass through that point. Okay, so let's get that equation quickly. We'll put -2 here still. And in place of x, notice I am putting -1. So this will be +1 this side. So when I take it to the other side, it'll be -1. So your C is -3. So it does look like this will be the equation of the other asymptote, this one right here. Okay, so when you sketch it in advance, something will happen, as you're noticing. Let me do it better. Okay, so now it's a bit better. That point should be on -3, like that. Okay, so this is what I wanted you to see. So the last one on this one, just do not collapse. Do this one as fast as you can so I can leave you alone on this. So do this one. Let's still call it function of x. Let's call it our number 3. We're not going to do much here. So I can do this fast since you already know what to do. So it's 2 over x minus 1 and then plus 4. I think you already have your y-axis and your intercepts. So if you have that, you know how to get them. Those are your y-axis and x-axis. As for your asymptotes, this one has been shifted 1 unit to the right. There. Okay, so it's 1 here. +1. And then it's +4. So it means we are up here. That's your horizontal asymptote on positive 4. Which quadrants are we in? Which quadrants do you think we are in? Well, as you can see, A is equal to 2, so we should be in the first and the third. I think now at this point you should know how to see your quadrants. So this will be a first quadrant. Do you see how difficult it is for me to actually try and put the other arm? So I do not know whether the other arm should be like this, or is it supposed to be like that, or something of that sort. So what will help me to draw the graph properly? That could be calculating your x-intercepts and your y-intercepts in advance. So it's about time I show you that you cannot always get away with it without your x-intercepts first. So I'm going to calculate my x-intercepts here quickly. Let's do it as fast as possible. 0 to x minus 1. You see, take 4 to the other side, it will be negative 4. So 2 over x minus 1. If I cross multiply, I'll have negative 4x plus 4 is equal to 2. And it means your negative 4x is going to be equal to negative 2, which will give us the x value. Is that so? Our x value now is going to just be a half. So let's write it like that. All right. So we know that the x value should be somewhat here. So now I know how this graph should look like. It should just look something of this sort, passing through a half. So that's one thing you have to be able to do. That one should be a half. But it's also important to get the y-intercept. It's also a critical point. So the y-intercept, all you have to do is to make x 0. So I'm going to do that quickly. So 0 in place of x, 2, 0 here, minus 1 plus 4. Okay, so it's negative 2 plus 4. I am getting a positive 2. So this time around, I drew it just fine. So please, people, this already is a curve we can accept, we can see, and we can see that it's a hyperbola. The equations of the asymptotes in this situation, we haven't been doing that for a while. Equations of asymptotes, how can you say them this time? Well, it is x is equal to 1 and y is equal to 4. And what else did I ask you? The domain and range. What is the domain of this? Well, x is an element of real numbers and x is not equal to the asymptote. So it's not equal to 1. What will be the range? Again, very simple. Y is an element of real numbers and y is not equal to the asymptote. And the asymptote is 4 in this situation. So this is all you were supposed to do. The excess of symmetry, I would like to hope that you got those ones right when you calculated them. Time no longer permits me to carry on. So this is what I had for you today. So in the next lesson, we are actually going to see if we can calculate more things on these hyperbolas, and then I would like to show you how question papers ask this type of questions. So thank you very much for watching this.